Hello everyone, welcome back to my channel. In this video, we are going to talk about what is draft handling and what is the advantage of draft handling. Okay, now let's take a use case one where user one is trying to create or edit some instance in a wrap application. Okay, so from the UI, he is trying to provide some set of columns, let's say like 10 columns, something. Okay, so usually, when the create or edit request will goes to the backend is by the time when user clicks create button or clicks the save button. Okay, let's say before he entered the save, suddenly the power goes up. So what would happen? So whatever the data user one enters will goes up, right? So let's take another use case where user 2 he is trying to create or edit similar kind of action. Okay, so he is entering set of input fields in the UI. Okay, then after some time he realized that he wants to upload some file. Okay, but this file is stored in the different tablet. Then what he is thinking, if he goes back to the tablet, he has to re-enter all the columns that he have provided already in the desktop. So he is thinking about some kind of a solution, like is there any way now I can continue my work in the tablet or any other devices. So for this both problems, okay, the user, there is a one solution called, we have to somehow store the user information in the backend. So typically in our web application, okay, you will be having a client, okay, that is user, which will be of course a UI, and you will be having a server. Okay, so whenever user wants something, he will send the request to the server and server returns back. Okay, so in our previous problems, so we can think about a solution of, so whatever user enters, so it should store some kind of a session in the backend server. User can able to not the by the server can able to remember whatever the user gives the values, and it can provide the response based on that. So this kind of communication is called a stateful communication. Okay, but typically if we think about cloud application, usually this solution will not be sufficient. Let's see why. So let's say user raises a request, okay, in the UI or something, and it connects to the always the internet, right? So there is something called load balancing. So basically this load balancing will reroute the request to the different servers according to the server availability. Okay, so basically there are a lot of servers in the real time. So when user sends the request, what would happen, this request might goes to server 1 or 2 or 3, right? So in our earlier solution, what would happen if let's say user 1 enters some values, and we try to keep the session of the user 1 in the server 1. Okay, here what will be an issue is the next request user enters, then the load balancing will be sending the request to, let's say it's server 3 2 or 3. Here we would miss the user details which was stored in the server 1, right? So there is some kind of dependency to the server here, right? So the stateful communication somehow will not fit to this our requirements. Okay, there's something called stateless communication with stateful capabilities. So before that we have seen what is stateful communication. Stateless communication is directly opposite to that. Okay, typically all HTTP requests will be a stateless communication where your request 1 and request 2 does not have any relation or does not have any communication. Okay, so how do we solve this? So the user is trying to type something. Okay, so if for a periodic time we need to send a request to the server, right? And what will happen after that, this whatever the server it goes, it should store that user details, whatever the data he enters, that should be stored in kind of some kind of a database table. So that database table we call it as draft database table. Okay, so this is kind of a temporary storage. So once this is just for we can't sure that this is the data will be stored always. Why? Because so user may think this could be a wrong input and he could change later point of time. Okay, this is basically draft handling. So using this we can store user details every period of time to the database tables. Okay, so let's see what is basically a difference between the stateless transaction and draft enabled application. Okay, so whatever we have seen so far, it's a stateless transaction up that is without draft case. Okay, so we have some kind of a transaction. Let's say like in the UI, I click on edit. What would happen until I save? Okay, my backend request will not get triggered, which means whatever I'm just editing here, that will not stored in the backend. Okay, so once I click on save only, then only it will get triggered and data will get stored. So the issue is if something happened in the middle, then we would lose our data what we entered. Okay. But what is the case of draft enabled app? So like the same kind of a transaction, let's say like I'm doing a edit, okay. Then after some few seconds or something, whatever we have entered, the small data which will be saved to the database tables. We don't need to click on the save button here. So the draft, if the application is draft enabled, so automatically the request will be sent to the backend and whatever we have entered, that will get stored in the draft table. Okay, so until when the real save button is clicked, then the real request will be triggered to the backend. The real request means the on the real instance. Okay, here the real database tables will get updated back. So till here your draft database tables will get updated. So once we click on the save, then all your active changes will be converted to the will be updated to the real database tables. Okay, so how do we handle the locking here? So in our same stateless transaction application, that is without draft scenario, what would happen is we use ETAG, optimistic lock. Okay, so optimistic lock is something uh, which will ensure that the data we are editing, that is as a latest version or not. Okay, so then the backend request will be triggered once we click on the save. So here what is happening, the locking will happen. Okay, so the locking will make sure that no data will be updated in the backend session, above session basically. Okay, so for normal case it will be a mix of ETAG and exclusive lock. So what if our application it's draft enabled? Okay, the same kind of a scenario, let's take a edit. So for certain time, it will be when you click on the edit button in the draft enabled mode, then the exclusive lock will be happen because you are editing the particular real instance, right? So after some time, you say like you left that instance and you are doing some other work. Then what would happen? The exclusive lock will become expired. Then after that, your optimistic log will be set. This is because so meantime the particular instance you are editing, that was not changed by someone else. So this will make sure. Okay, So once you come back and you try to resume it, that time your exclusive log become enabled, and you can simply edit without any other interruption. So this is the uh, uh, log and some kind of concurrency control handling, okay, in the draft enabled mode. So this is the short overview about draft handling. So if you like this video, kindly do thumbs up and subscribe for more videos. Thank you for watching. Have a great day.